Hi, good day to all. So, for today, I'll discuss a topic about differential equations involving word problems, especially Newton's law of cooling. Newton's law of cooling is based on this proportionality equation. D capital T over d small t is proportional to T minus Ts, where T is equal to the temperature of the body or object, Ts is equal to the temperature of the surroundings, small t is equal to the time, and K is the proportionality constant. Moving here, if you replace this into the equal sign, there will be a proportionality constant. So to integrate it, dt over t minus ts is equal to the integral of k dt, which will lead to the primary equation, which is ln, absolute value of t minus ts, is equal to kt. The problem is, a chef prepared the steak. The temperature of the served steak was 35 degrees Celsius. After 5 minutes, the temperature of the steak went to 29 degrees Celsius. You want your meal reheated and to be served in 5 minutes. What should be the temperature of the microwave oven to make the steak 40 degrees in 5 minutes? So obviously the problem is about temperature. So we will use Newton's law of cooling. So in the solution, first I'll give you a tip. Create a table including time, temperature of the steak, and the temperature of the surroundings. So as we will read the problem, at 0 minutes, the temperature of the steak is at 35 degrees Celsius, and the temperature of the surroundings is at 27 degrees Celsius. At 5 minutes, so after 5 minutes, right, the temperature of the steak went down to 29 degrees Celsius, so it became kind of cold, and the temperature of the surroundings is still 27 degrees Celsius. And then let us say the problem is like instantaneous, so after 5 minutes you then put it in the oven, so instantaneously, okay, so after 5 minutes again, so it is actually 10 minutes, the temperature of the steak is 40 degrees Celsius, and the temperature of the surroundings, which is in the microwave oven, is X degrees Celsius. We don't know. Okay. Using the formula for Newton's law of cooling, we will write dt over t minus ts is equal to k dt. Alright? So, in this formula, we will integrate it. Alright? So it will be ln of t minus ts, t which is the temperature of the steak, and ts which is the temperature of the surroundings, is equal to k t, which is k, the constant, and t is a time. We are given with t, we are given with ts, and we are given with t. So we need to find the constant of integration, which is k. Next page. So in the next page, we will write ln t minus 27 degrees Celsius, which is actually this. Alright, ln 27 degrees Celsius, and which goes from 35 to 29 degrees Celsius. So we'll write here 35, this 29 is equal to k t. where t goes from 0 to 5 minutes. Putting all the data in, it will be ln 29 minus 27 over 35 minus 27 is equal to k from 5 minus 0, which will lead us to k is equal to 1/5 ln of 1/4. This is actually the absolute value. This one. Now, the only missing part is the x, which we need to find out. So, in the next steps, you need to use this again, this formula. This is very important. This formula, and input x in TS. Okay, so putting it there, it will be ln t minus x from 29 40 degrees Celsius is equal to k t from 5 to 10. So, putting it all in there, which ln 40 minus x over 29 minus x is equal to k, 5k. ln of 40 minus x over 29 minus x is equal to 5 over 5 ln of 1/4. So to remove the ln, it will become 40 minus x over 29 minus x is equal to 1/4, which will become 160 minus 4x is equal to 29 minus x, which will give us to x is equal to 43.67 degrees Celsius. So, the temperature of the oven to give us a 40 degrees Celsius steak in 5 minutes is 43.67 degrees Celsius.
Hello, today I'm going to talk about an application of differential equations, specifically decomposition and growth. So, for its theorem, decomposition or growth is proportional to the number of substance present at any time t. So as you can see here, I have set up an equation that says so. And using our knowledge of differential equations, we would solve this by using variable separable. So by integrating both sides, you would have ln of x is equal to kt plus c. We would raise all of these by e to solve for x. So we would get e raised to kt plus c is equal to x. And by substituting e raised to c by c sub 1, you would have this. And by using the initial amount, which would be given by the problem, and the initial time, that is 0, you would get c sub 1 is equal to the initial amount, and this would be the solution. And for a sample problem, we would use bacterial growth. The Escherichia coli is a species of bacteria that is able to reproduce at a certain rate. The rate at which this bacteria reproduces is proportional to the amount present. A petri dish containing this bacteria is left open. 10 minutes later, there contains 1.5 grams of the bacteria. 15 minutes later, The bacteria are now thrice of the original amount. Find the constant of growth. Find the amount of bacteria at A present originally and at B amount of bacteria at 15 minutes. So we would know that this is a decomposition and growth problem, since it already stated here that the rate at which this bacteria reproduces is proportional to the amount present. So first of all, it is best to set up a table that has the following details. So at the initial time, we would have the initial amount 10 minutes 1.05 grams, and at 15 minutes 3 times the initial amount. So first, we use the theorem dx is equal to kt. Now we would integrate both sides, but setting up our upper limit and lower limit based on the data that we have. First, we would use the data, the initial time and the initial amount, and the time at 10 minutes and 1.505 grams, since these are given. Now, by integrating both sides, you would have ln of 1.05 all over x naught, or the initial amount, is equal to 10k, or 10 times the proportionality constant, and we would divide both sides by 1 over 10, and we would have this. Now we will set up another equation, but we would use other given. So at time 10 minutes and 1.505 and 15 minutes and 3 times the original amount. So we would have this. We would substitute k with what we got earlier so that it would be solvable. So here we would get 1 over 10 ln of 1.05 all over x naught multiplied to 10 minus 15, which is the integration of dt. You would have ln of 1.05 all over x naught, or x sub 0, minus 15 over 10, as you can see here. Then we would simplify this by subtracting both sides. We would get 5 over 10 ln of 1.05 all over x sub 0. And this would give us a result of ln of 0.98 multiplied to x sub 0 raised to 1/2 is equal to the integration of this one, which would give us ln of 1.05 over 3 times the initial amount, or 3 times x sub 0. Would raise everything by e, so that we would get this. Then solve for x naught, we would have 0.5034 grams. Now, we would have to get the amount at 15 minutes, which is 3 times this amount. So 3 times x naught, or 3 times 0.5034, you would get 1.5102 grams. And by solving for k, substitute the value of the initial amount of bacteria with this. We would have an equation of 1 over 10 ln of 1.05 and by solving this, you would get 0.074. That's how you would solve a decomposition and growth problem. Thank you.